This is Equillibrium Island, problem number 8. In the summer, the island gets very hot, and so do the people's tempers. This makes people less likely to be in the married state. Assuming that the marriage rate drops to 30% while the divorce rate climbs to 50%, show how the number of couples will adjust to form a new equilibrium during the summer months. So in the previous one, in number 3, the equilibrium ended up at 750 couples at the end of the day and the start of the day, and that was our equilibrium. So now we're going to see how the equilibrium changes with this change in rate of weddings and divorces. So in order to calculate the end of couples, the end of day number of couples, we're seeing the couples, original amount at the start of the day, plus the amount of weddings that day, minus the amount of divorces that day. So we'll start with the first one. To get the amount of weddings, that's 30% of singles wedding, that would be 75. And divorces, 50% of breakups comes from our couples, 375. So if we add together 750 plus 75 minus 375, we will get 450. This becomes our amount of couples for day 2, 450. And if we subtract this from 1,000, which is the amount that we have total, we get 550. And so it just follows this same pattern. So 30% of 550 is 165. 50% of 450 is 225. And our total couples at the end here is 390. And I'll go ahead and fill in the rest of the chart. And for the equilibrium, I will round this to 375. So that is our final equilibrium. It will always now remain at 375 couples, 625 singles, because the number of weddings equals divorces. So let's talk about the algebraic solution here. Let's list out some equations that we know to be true. We know that couples, which I will represent as C, plus singles equals 1,000. That is something that is always true. 750 plus 250 is always 1,000. 450 plus 550 is always 1,000. This is always 1,000. We also know that the rate of weddings is 0.3, which is 30%, times our single amount, and our amount of divorces is 50% of our couples that we have. When our rates are the same, weddings equals divorces, that means that if we subtract our weddings from divorces, that should equal 0. So 187.5 minus 187.5 is 0. That's when we get to equilibrium. At equilibrium, the amount of weddings minus the amount of divorces should always equal 0. That's true for any equilibrium. The rate forward and the rate back is the same. So if we do the amount of weddings, which is 0.3s, minus the amount of couples getting married or divorced, which is 0.5c, that will equal 0. And so we can do some algebra here, some rearranging of our equations to substitute one variable in for another. So I'm going to rearrange this second equation. I'm going to add 0.5c onto the other side. So we get 0.5c equals 0.3s. And I am going to solve for s, which means I'm going to divide by 0.3, divide by 0.3, and I will end up with, and I'll leave it like this, 5/3 c equals s. Now I have something that equals s, and I can put this in over here, and that will let me simplify my variables here. So I've got c plus 5/3 c equals 1,000. And remember that there's a 1 here, but instead of 1 you can write 3/3, same thing as 1, and we can add our c's together and end up with 8/3 c equals 1,000, because we're trying to find out how many couples we have, because remember, that's the equilibrium number. And so if we multiply by our reciprocal, we end up with c equals 375, which is our equilibrium amount. This is just one way to solve it algebraically. There are others, and that is how you do this one.